discuss about the architectures which we will use between when switching between two technology, merging the two technologies. Just there are there are main two type of architectures: tight coupling and loose coupling interworking. And third one is a mixture of these both technologies. Just the in tight coupling, WLAN gateway is directly connected with 3G, and it pretend to be as a part of 3G radio access network. WLAN gateway hides all details of WLAN networks from 3G core, and it installs mobilities and other protocols which are required to communicate with the 3G that based on 3G technology. And on mobile node side, 3G control protocols stack is implemented on the top of 802.11 standards network cards. Traffic generated by the client in the WLAN is injected into 3G core network by using the 3G protocol stack instead of using the WLAN protocol stack. So these are the disadvantages because it needs a proper integrated WLAN networks. So, and careful engineering network planning tools required to deployment of 3G network and issues on mobile nodes, just like implementation of 3G stack on WLAN card. This is the diagrams of this one. Here you can see it's WLAN and it's 3G network. It is directly connected with this, and this will work as a part of 3G network. And in loosely coupling interworking, WLAN gateways not directly connected with 3G network. It works as an independent. And high-speed data rate traffic of WLAN is not injected into the core network of 3G. Independent deployment and easy traffic engineering between 3G and WLANs without intensive capital investment, these can be merged together. These are the disadvantages: increase the data latency in the real-time application, and seamless operation is only possible if all functionality is operated properly. This one is a diagram of loose coupling. Here you will say this WLAN is connected with internet instead of connected with 3G interworking. And hybrid coupling is the combination of both networking, tight coupling with this and loose coupling with this. And here real-time application data can be sent with this because it requires a low latency. Others that are not real-time, just like email, FTP servers, can be sent through loose coupling. Now we will discuss about the approaches of handovers. We use the concept of mobile IP, and I will try to explain the process from how it's going into different steps, and because it's not 4G is not implemented yet, it's in process. And these are the some just like stages how they are going to achieve this goal.
Please think about the time. We have less than 5 minutes left.
Okay. First, it's a concept of mobile IP. In mobile IP, there are two agents work at the node which is attached. It work as a home agent, and where it is going to attach, it work as a foreign agent, and mobile node which is moving, and corresponding node which communicate with the nodes. And it's mobile IPv6. In mobile IPv6, there was a concept that layer 2 and layer 3. Because of short of time, I will just give an overview. First, the process of layer 2 is completed, then the process of layer 3 is going on. So it is work in a sequential. Instead of that, another solution came in that fast mobile IPv6. In fast mobile IPv6, there are two modes. One is predictive mode and second one is reactive mode. In predictive mode, first layer 3 process is completed. When layer 3 process is completed, its layer 3 process is completed and it disconnected and then search the others one and connect other one side, then these packets are forwarded to the, I will discuss this in my solutions in detail. And we are using in our case this, we are forcing our procedure to work on predictive mode instead of working on reactive mode. It's a reactive mode. In reactive mode, layer after some communication, it disconnect and connect with other sites, then start to communicate with the previous node. These are algorithms which we designed for our handover. First, I will discuss that now our device is working in WLAN. These are some parameters on which it will decide either it should move into WLAN into 3G or it will not. First, it will check if SIR of WLAN is less than the signal to interference ratio of required application, or velocity is greater than the threshold velocity, and the received signal strength of the other sides, UMT, is greater than the received signal strength of threshold, then and the UMTS satisfy the requirements of the application, then it will start a dwell timer. Dwell timer is specified sometime if the same conditions persist sometimes until the dwell timer is expired, then it will execute the handover and to go into UMTS. Else reset the dwell timer or trigger passive or active if it's happened. Okay, you can switch. First it will decide, then trigger. If it's not, then it will search the another WLAN. For other, it will send passive or active WLAN network scanning and start scanning and compare overs parameters and the others parameters. And then it start again dwell timer, and if condition satisfied, it executes the handover, otherwise remains with the same technology. Second. This one is second one, working in UMTS and want to switch in WLAN. If velocity is less than threshold velocity, or terminal power is less than the threshold of terminal power, and received signal strength of the other side is satisfied. If these conditions satisfied, then start dwell timer. If dwell timer same persist, then it execute handover, otherwise reset dwell timer and repeat the same process and stay in the current technology, mean in 3G technology. And here we will discuss the whole procedure from one, how it will convert from one technology to other. Due to time shortage, I will just discuss one from handover of UMTS to WLAN. It's a whole procedure which will describe the from one technology conversion of the other. And all the concept the problems and concept we will discuss above in the introduction. Here we can see the answer of all these things. Just at the start, it's a mobile node, and it's 3G and it's WLAN. Again, here we use the mobile node. At the start, layer 2 of mobile node send a message, link is going down to its layer 3 device, layer 3. Then it communicates with the GGSN, it send a router solicitation proxy, and then handover, it request, then it send handover initiation to the WLAN. It sends the SSID of its nodes and request for a care of address. In the reply, it sends a care of address for the nodes, because when it will connect with the other side, it use the same address. And proxy router advertisement contains the new address. Now mobile node have a new care of address.